Today we are going to solve equations that have log on one side, and if you know how to change forms, you basically know exactly what to do. Once the log is isolated, you do the log ride. So, woo! A to the x equals y, which is basically what's written right there. So, once the log is isolated, change forms, and then you'll be able to figure out the rest of the equation. So number 13. X is currently stuck inside the log. There's nothing added or subtracted after the log. There's nothing multiplied in front of the log. So what we need to do is the log ride. Change forms. Start with your 2. 1, 2, 3. Woo! 2 raised to the negative 1 equals x. By changing forms, it gets that x out of the log and allows you to evaluate whatever else is in the equation. 2 raised to the negative 1 is 0.5. So 0.5 equals x. Okay, number 14. I'm going to write in here, and you should write this in your notes. You cannot subtract 22 yet. After the parentheses, there's no addition or subtraction. In front of the ln, there's no multiplication. So this is isolated. What base is ln? Ln is base e. So when we change forms, woo! E to the third equals x plus 22. E to the third. Grab your calculator, find your ln button. You can do e to the third. Second button, ln button to get your e function. E to the third is 20.086. Okay, now you can subtract 22. That 22 is no longer stuck inside the log, so now you can subtract it in order to finish solving this. Our answer is negative 1.914. Examples on the next page. On number 15, well, do you want to do 15 or 16? Which one do you want to do? Let's do 16 first. Okay, so on number 16, you need to isolate the log first. The first step is always to isolate the log. And that may involve adding or subtracting. You always add or subtract first, and then either multiply or usually divide. So, do you notice the plus 15 in number 16? We need to get rid of that first. So we're going to subtract 15 on both sides. That will give us 2 times the log base 2 of x equals 16. That log is not isolated yet. We still have to get that log completely by itself. So next we need to divide both sides by 2. So log base 2 of x equals 8. Now the log is isolated, so your next step is to do the log ride or change forms. 2 to the 8th equals x. And 2 to the 8th you can easily calculate in your calculator. 2 raised to the 8th is 256. I would like you to try number 15 on your own. Keep in mind, don't forget that ln means base e. So number 15 is probably going to work out to be some crazy decimal. That's okay. Try number 15 on your own. Number 15, first subtract 7 on both sides, then divide by 2. Then remember that ln means log base e. So when you do the log ride, you have to do e raised to the 3.5 equals negative x. e to the 3.5 is approximately 33.115. And if that equals negative x, then negative 33.115 would be positive x. How do you feel about 15 and 16? Okay, let's move on to number 17. We are probably going to skip number 18, just so you know. In number 17, the problem is that we have 2 logs on the left side. And in order to solve this, we need to isolate the log. We need to just have 1 log on the left side. So our first step is going to be to condense. So I'm going to write the steps in here. Our first step is to condense the log. Remember that addition between the logs means multiplication inside. Okay. Once you condense the log, your next step is to change forms. Do the log ride. Woo! So 2 to the 3rd equals x times x minus 2. In the next step, I'm going to do a couple of things. I'm going to call this step simplify. 2 to the 3rd, I can do that in my calculator. 2 to the 3rd is 8. And I can distribute here and get x squared minus 2x. And now I notice, oh man, I have x squared and x in the same equation. That means I need to get one side equal to 0. So subtract 8 on both sides. So we have x squared minus 2x minus 8. We are going to hope that these factor. Sometimes they don't, but often they do. Our next step is to attempt to factor. We are looking for 2 numbers that multiply to give us negative 8. So I put a little multiplication symbol over the negative 8. Those same 2 numbers have to add up to the negative 2. So I think it's probably 2 and 4. To add up to negative 2, the negative would have to go with the 4. Once you have this factored, your next step is to solve. So if the factor is x plus 2, the solution is x equals negative 2. If your factor is x minus 4, your solution is positive 4. Anyone want to take a guess what the last step is? Anytime you get more than one solution, you really need to check. And here's the thing. You don't actually have to check to make sure that it mathematically works. You don't really have to make sure that the 2 sides are equal to each other. What you're really checking for is, does one of these solutions create a mathematical situation that can't exist? So take a look at the original equation. We have log base 2 of x. If we plug in this negative 2, we'd have log base 2 of negative 2. Can we plug a negative number into a log? We cannot do it. That solution, x equals negative 2, creates a mathematical scenario that can't happen, so that is an extraneous solution. The next one, we plug in 4, we would have log base 2 of 4 plus log base 2 of 4 minus 2 is 2. You could, if you wanted to, take the time to make sure that the log base 2 of 4 plus the log base 2 of 2 actually equaled 3. It's probably going to. So you don't really need to take that much effort in checking. You're really just making sure that the solution 4 does not create a mathematical situation that can't exist. This one's fine. It's positive numbers in the logs, so we're good. That is our solution. Okay, a couple weeks ago, we did this problem, but we didn't really know how to solve these, so we had to guess. Do you remember when it was like, after how many years will the population be whatever? And we had to plug in 5, plug in 10, and try to find how many years would work. This time, we know how to solve it. So you deposit $150 in an account that earns 3.5% annual interest compounded continuously. How long does it take for the balance to reach the following amounts? When it says continuously, that means you're using the PERT formula, PE to the RT. P stands for the principal, which is the starting amount. A stands for the amount after T years. So after T years, we want the amount to be $170. So we put 170 in place of A. We started with 150. Our rate, R, is 3.5%. To write 3.5% as a decimal, it would be 0.035, and T needs to be in that exponent. So before now, we didn't know how to do this. We would have had to just plug values of T in until we got something close to 170. But now we can actually solve this. This is 150 times E, so we can divide both sides by 150. We get about 1.133. We have to do the log ride. We're stuck. T is in the exponent. We're stuck. This is actually an exponent on one side problem. This isn't a log problem, but an exponential problem. So start with your base E. You always go to the other side of the equal sign. So E, woo, around that way. You'd have log base E of 1.133 equals your exponent, 0.035t. Log base E is ln. So to figure out what that is, punch ln into your calculator. This thing means ln. So ln of 1.133 0.125 and then your final step to get T by itself. Okay, sorry about my voice. Your last step is to get T by itself, your last step is to divide by 0.035, and that will give you an answer 3.571. So that's about 3.6. T represents years. So how long does it take for the balance to reach $170? About 3.6 years.